Hi guys, welcome back to Enginerds YouTube channel. My name is Patricia Bermudez and I will be your host for today's video. And for today's video, we will be continuing on the ideal gas equation. But for this one, we will be focusing on gay-Lussac's law and Boyle's law. So the question states that a particular balloon is designed by its manufacturer to be inflated to a volume of no more than 2.5 liters. If the balloon is filled with 2 liters of helium at sea level and rises to an altitude or to a height at which the boiling temperature of water is only 88 degrees Celsius, will the balloon burst? So we know from here, from the problem, that the balloon will burst if V is greater than 2.5 liters. So we just have to find V. That's the goal of this problem. You have to find V at this altitude where the boiling temperature of water is 88 degrees Celsius. So first, we're gonna focus on Gay-Lussac's law, which states that volume is constant. So using the ideal gas law, PV is equals to nRT. If you're gonna take P1, and then the volume is constant, and then nr is also constant, and then you have T1, and divide that by the final condition. Kung nung nasa altitude na siya, nasa height na, we have P2, volume is constant, so it just remains at V. So ito, nr, and then T2. Makita natin na makakancel yung V, makakancel yung N, makakancel yung R. So we have P1, P2 is equals to T1 over T2. And that is Gay-Lussac's law. And here, we have to first find the pressure at the altitude. So first find pressure at the said altitude or height. And the question here is, does your pressure increase as you go up or does it decrease? We can use an analogy here. Like, for example, the simplest here is, for example, this is the sea. Sa dagat ka, right? And then, habang bumababa ka or habang sumisisid ka sa dagat, yung, you feel na parang may umiipit sa'yo, right? I don't know. Personally, I feel that way. So, that is because pressure is equals to force over area. And we can calculate force using the weight on top of the reference point that we are measuring at. So we can say that force is weight over area. Okay? So yung weight natin here, for example, you're here, ikaw to. Yan. And then you're at the bottom of the sea. And then you have all this water weight on top of you. When you have a lot of this weight on top of you, your force increases. When your force increases, your pressure increases as well kasi it's directly proportional. So, ayan. We can infer from here that as you go down the sea, your pressure increases. But how about when you go up to an altitude, which is, for example, gamitin nating reference naman this time ay bundok. Like, tataas ka. That's how you go up to an altitude, right? Either climb a mountain or you go up a building or something. So, yan. For example, ay, ito yung sea level. Let's use block. Sea level. Sea level, parang reference siya na kung saan tayo normally gumagalaw as humans. Kung saan tayo, kung saan nasaan yung lupa. That is sea level. And then, for example, there is a mountain here. Okay? And then here. You're here. This is sea level. Sea level. And when you go up to a height, like for example here, let's say dito, yung air molecules mo naman, kanina ang ginamit nating reference ay yung weight ng water. But then this time, we're gonna use the weight of the air molecules. When you go up sea level, when you go up, yung air molecules mo ay mas kumukonti na. Or I don't know. I think it's much more dispersed, like sa height or something. I'm not really sure. But here, we can use the same analogy that we used earlier. Na as you go up the mountain, yung weight that you have, for example, nandito ka na, yung air molecules here, nandito pa rin. Hindi naman siya umakyat kasama mo. It's still at sea level. So when you go up, yung weight on top of you is lesser. Kasi umakyat ka eh. So lesser na yung air molecules mo on top of you. And because of that, your force or the weight of the air molecules decreases. And what happens to pressure? It decreases as well. So we can say that as you rise up the mountain or as you rise up to a height, your boiling point decreases because your pressure decreases as well. Okay? So, ayan. From here, we can infer na bababa yung pressure mo. And we can verify that using gay-lussac law, assuming that volume is constant first. Okay? So, what we're gonna do is, we're gonna use P1. And we have to know that at sea level, yung pressure mo, let's say ito, P1, is 1 atm. And yung boiling point mo is 100 degrees Celsius. Kasi ang boiling point here sa lupa is 100 degrees Celsius. Okay? And this one we can use this as T1. And then ang hanapin natin ay T2, right? So we can take the inverse of this again. So we have P2 over P1 is equal to T2 over T1. So yung P2 natin is equals to P1 times T2 over T1. So we just substitute that here. But first, we have to convert Celsius into Kelvin kasi we cannot take temperatures, we cannot take the ratio. We cannot put Celsius into a fraction kasi they are not absolute temperatures. So yung P2 natin is yung P1 which is 1 atm. Plus yung T2 which is yung boiling point at the altitude. Kasi yung P2 ang hinahanap natin and this one dapat nakarelate siya sa boiling point dun din sa altitude na yon. So 88 plus 273.15. So we're converting it into Kelvin divided by the boiling point at sea level, which is 100 plus 273.15 Kelvin. You can see na makakancel yung Kelvin and titira yung pressure in atm. So yung pressure here, we have 0.96 7841 3507 atm. And this is the pressure at the height. And now the second step is to find volume at the said height. Dito na natin gagamitin yung Boyle's law, which states that temperature is constant. Kasi we're not talking about, kanina, nagbago yung temperature, and this is the boiling temperature of water, and we only used it as reference to find pressure. Pero dito, we assume that the temperature, whether or not you go up to an altitude, is constant para makita natin yung change ng volume according dun sa change in pressure. Okay? So, ayan. Dahil constant yung temperature, again, using PV and RT, we have P, let's say P1 V1, kasi yung P and V nagbabago, and then is equals to nRT, yung T is constant, and then you divide it by the final condition, which is P2 V2 is equals to, divided by the nRT, and since constant yung temp and constant yung temp, constant yung nR, cancel to, and therefore this is just equal to 1. So we can relate this to become P1 V1 is equals to P2 V2 kasi we transpose this sa yung denominator natin here. Kaya siya naging ganito. And this is Boyle's law. So now, ang hanapin na lang natin is yung V2. So V2 is actually equal to P1 V1. Itong P2, lagay natin sa denominator, bring it underneath. So, ayan. So yung V2 natin then becomes yung P1, which is yung P1 natin is the pressure at sea level. And this one is the volume at sea level. And this one is the pressure at height. And this one is the volume of balloon at the height. So, yung V2 natin is, yung P1 is 180 m kasi sea level, times yung volume at the sea level, which is here, 2 liters. So, 2 liters divided by yung P2, which is the pressure at the altitude, which is this one. So, it's 0.9678413507 ATM. You can see na makakancel yung ATM natin. So, yung V2 is equal to 2.066454382. And since this one is lesser than 2.5, this one is in liters, and since it's less than 2.5 liters, we can conclude that no, the balloon will not burst. So, yep, we have found our answer for the problem. That is our solution for the problem. I hope you learned a lot from today. Thank you for listening and stay tuned for the next one. Bye-bye.